Now we're on page 3 of the AP Chapter 8 and 9 packet, and we're again finding the lattice energy of sodium chloride, but this time we're going to find it using what's called Hess's law. You'll recall that last notes we said that lattice energy equals delta H minus stuff. What I would recommend is changing that formula and solving so everything is positive. So now we're going to see that the stuff plus lattice energy equals delta H for this method, okay, for Hess's law. This method appeals a little more to the mathematical side. The other one appeals more to the picture side, if you like pictures more. So what we're going to do is we're going to find the delta H, the lattice, and the stuff all together and solve for the missing one. In this case, the lattice is going to be the missing one. So let's start with delta H. We're going to actually go to the bottom of our page here, and we're going to write down the equation for delta H, because delta H is the sum of the lattice plus the stuff. So delta H is forming 1 mole of something, in this case the sodium chloride, from its elements in their standard states. So sodium is a solid, chlorine is a gas. We only need a half of it because there's only 1 chloride in there. And the delta H is negative 411 kilojoules. Now what we're going to do is put the lattice equation right here. So the lattice is forming 1 mole of a ionic solid from its gaseous ions. So the Na has to be a positive 1, and it's a gas, and the chloride is also a gas as a negative 1. And this is actually the number we don't know for this problem. Now, what I like to do whenever I do a Hess's law problem is I like to circle the things that I already got that I know I need. So I got the sodium chloride solid, I got that here, and I'm good with that. But now I have to get all this into the right ones for getting the Na. So we're going to write down the first one is going to be the ionization energy. Okay, so ionization energy of sodium. Remember what ionization energy is? It's the energy required to take away an electron from an atom or ion. So if you start with Na, this is ionization energy. By the way, this purple was the lattice. So stuff plus lattice gives delta H. So sodium solid, Na solid. You want to change that into Na plus and electron. That's called ionization energy, and it tells you that's 496. So you write the 496 right here. Now look at what happens. This, and by the way, this is a gas. So, oh, I'm sorry. Oops. This is a gas right here. This is a gas. Okay, so what I can do is notice that this is going to cancel out this so far. All right, now I'm going to look at the sublimation. So Na solid goes to Na gas. And that sublimation energy is up top, and it tells you that is 108. So that's 108 kilojoules. Now notice that the Na gas cancels out here, and look at what I got down here. Na solid, Na solid. So that was called sublimation. Okay, the next thing is going to be the chlorine, and let's do the bond energy for that. So we have that 1/2 Cl2 gas will yield a Cl gas. That was called bond energy. And remember that the bond energy was 240 kilojoules. However, that's for breaking up an entire Cl2, but we only need half of it, so you'd only need half of that. And notice that this is going to be right here. And lastly, we need the electron affinity of chlorine. So chlorine gas, remember the definition of electron affinity is you give it an electron to make Cl minus. And that electron affinity is given as negative 349 kilojoules. And so look at what happens here. We have our 1/2 Cl2 we got. So we're going to cancel out this and this. And notice from here, we're going to cancel out this and this. And we will also cancel out electron and electron. And then what you do is you have to say all the stuff, which is the red, plus x is going to give you the green. And when you do the math for that, it's going to be negative 786 kilojoules, because all these are in kilojoules as it says in the top of the paper. So all these are going to add up to negative 786. Okay, as with the diagram I gave you before, remember that if you had something like MgCl2, you would need to have 2 of the chlorides come into the picture, because you need 2 of them. So you'd actually have to not have a 1/2 there. You'd have to have both chlorides, and this would be a 2 right here. And then you would also need to have 2 electron affinities, 2, 2, 2, which would mean you multiply that one by 2. And then not only would you have to have a first ionization energy, okay, but you'd have to have a second ionization energy, and then you'd have to have a number there for that as well, because Mg has to lose 2 electrons. So we'll get some practice on that later. I just wanted to mention that on this video, just like I did on the last video. What you do need to do is you need to pick which method do you like better. Do you like adding all up these equations and writing them pretty much from your head, or do you like just drawing the picture and putting the numbers in? Whatever way you like, I would just pick one way and stick to it. The book will pretty much tell you the Hess's law, although it does have pictures as well. I would pick one method and stick to that method.